Today we're going to be covering zero and negative exponents day number 1. Content objective is students will be able to simplify expressions with exponents that are negative and zero. Language objective is students will be able to discuss patterns associated with negative exponents. Why am I learning this? Well, it's important for real-world problems like representing the size of something very small, such as the diameter of a white blood cell. Okay, so let's go ahead and read the first problem. It says, we can think of powers of 2 as repeated multiplication. Fill in the pattern of powers that are not negative. What does this lead you to fill out for 2 to the 0? Okay, so let's start with a list. First, let's start with 2 to the 4th power. What does it mean? It means 2 is being multiplied 4 times. So I'm going to write that out. Well, let's figure that out. 2 times 2 is 4. Whoops. Let's try this again. 2 times 2 is 4, and then 2 times 2 is 4, so 4 times 4 is 16. Okay, so let's try the next one. What does 2 cubed mean? It means 2 times 2 times 2. It's repeated 3 times. 2 times 2 is 4, times 2 is 8. Okay, what does 2 squared mean? It means 2 times 2, so 2 times 2 is 4. What about 2 to the 1st power? Well, that's just 2 repeated once, so that's going to equal 2. So now, what about 2 to the 0? What would I write there? I don't know. So let's look at the numbers that we ended up with, and let's see if we can figure out a pattern. We went from 16 to 8 to 4 to 2. Hopefully, you can see that every single power, when it decreased, we ended up dividing each by 2. So, for example, 16 turned into 8 because we divided by 2. 16 divided by 2 is 8. How does 8 become 4? Well, 8 was divided by 2. Again, how was 4 turning into 2? 4 was divided by 2 to give you 2. So now the next question is, then if we continue this pattern, what would 2 to the 0 be? Well, 2 divided by 2 would be 1. So the answer of 2 to the 0 would be 1. In fact, you're going to see this with all numbers. Any number raised to the power of 0 will be 1. And we're going to see this more in detail in tomorrow's lesson of why it's 1 and not any other number. Now let's go ahead and read the second part of the question. It says, if positive exponents indicate repeated multiplication, the negative exponent should indicate blank. So let's figure it out. Okay, so first we're leaving off with what we already had, which was 2 to the 0. We did figure out is 1. So we did figure out, okay, I was dividing by 2 every single time. So the pattern should continue on. So now what's 1 less than 0? It would be 2 to negative first. So if I take 1 and I divide it by 2, I end up with 1/2. Okay, well, what about the next power? It will be, what's 1 less than negative 1? Negative 2. Okay, well, if I take 1/2 and divide by 2, that will leave me with 1 over 2 times 2, which would be 1/4. Okay, let's keep going. 2 to negative third, I would again just divide by 2. So 1/4 divided by 2. So basically, we're dividing 2 a total of 3 times now. Like so. This would become 1/8. Okay, so the next one, if I continue, I'm going to go ahead and divide by 2. It's going to add another 2 in the denominator, essentially, giving me 1 over 2 to the 4th, which would give me 1 to the 16th. So hopefully you're starting to see what's happening and what negative exponents does to the base. Okay, but we need to see now that when we see negative exponents, essentially, it is repeated division. Okay, so now let's do some quick comparisons so that we can see a better idea of the relationship of negative exponents versus positive exponents. 4 squared is 4 times 4. 4 to the negative second is 1 over 4 times 4 because I'm dividing by 4 2 times. Okay, so 4 squared is 16, but 4 to negative 7, 4 to the negative second is 1/16. Okay, let's look at another example. 3 cubed is 3 times 3 times 3. 3 to the negative third power is 1 over 3 times 3 times 3, because I am dividing 3 3 times. So here we would get 27, but here I would get 1 over 27. So compare 16 to 1/16, compare 27 to 1/27. Okay, what about 2 to the 4th? That means 2 times 2 times 2 times 2. 2 to the negative 4th is going to mean 1 over 2 times 2 times 2 times 2, because I'm doing 1. Why am I always using 1? Well, it's because 2 to the 0 was 1. 4 to the 0 would be 1. 3 to the 0 would be 1, etc. Anything raised to the 0 power is 1. So I start at the 0 power because that's the middle ground. And if I have positive exponents, I multiply, but if I have negative exponents, I divide. And so I divide it by 2 a total of 4 times. So here I have 16, but over here I have 1/16. So again, compare these numbers when the exponent is positive versus when it's negative. Okay, 5 squared, what does it mean? It means 5 times 5. 5 to the negative second, what does it mean? 1 over 5 times 5. So here the answer evaluated would be 25, but here the answer evaluated would be 1 over 25. Again, make that comparison. So now what I would like you to do is go ahead and pause the video and try the next 4 problems on your own and compare them. And I want you to come to a conclusion of what happens when your exponent is positive versus when your exponent is negative. Okay, so go ahead and pause and try it on your own. Okay, so let's see how well we did. Hopefully you saw 2 cubed is just 2 times 2 times 2, but 2 to the negative third power is 1 over 2 times 2 times 2. So you have 8 versus 1/8. How about 3? 8 squared would mean 8 times 8, but 8 to the negative second would be 1 over 8 times 8. Okay, so you have 64 being for the positive exponent, but then for negative exponent, you have 1 over 64. So I'm just going to go ahead and go over the answers with you really quickly so that we can go ahead and take a look at what we notice. So here we notice that if our exponent is positive, okay, we end up with a whole number, but when our exponent was a negative exponent, it ended up being the reciprocal. So here, 8 is what happens when you take the whole integer and you cube it, but when it's that integer is raised to the negative power, it actually ended up as the reciprocal. So instead of 8, you take the reciprocal and it became 1/8. Same thing here. The integer to a positive exponent was a whole number, but the same base raised to a negative exponent was the reciprocal. So here, 64 over 1, the reciprocal was 1 over 64. So just a quick reminder, reciprocal is when you take the fraction and you flip it over. So again, positive exponent, you have an integer, but when an integer is raised to a negative exponent, you take the reciprocal of it. Same thing here. 7 to the second power is 49, but 7 to the negative second power, it's the reciprocal of that, which leaves you with 1 over to the 179th. I keep saying numbers wrong. 149th. Okay, so now that we know a little bit more about using what we know about positive exponents, let's go ahead and make a conclusion of what we've realized about zero exponents and negative exponents. Okay, so let's take a look. We figured out now that any number raised to the 0 power is 1. Okay, the only exception that you have to understand is you can't take 0 to the 0 power. Okay, the base has to be a number that is not 0. Okay, so therefore anything raised to the 0 will always be 1. The second thing that we learned about negative exponents is essentially when a base is raised to a negative exponent, we just simply take the reciprocal of it and we raise it to that power. So quick example, one more time. If I had 4 to the negative third power, instead of taking 4 repeated 4 times, I'm actually going to take the reciprocal of it, which is 1/4, and I will cube the 4 here. And again, it comes along with the fact that negative exponents is essentially repeated division. So you start with 4 to the 0 power, which is 1. And here, because it's a negative exponent, I'm not going to multiply by 4, but instead I'm going to divide by 4, a total of 3 times, like so. Okay, so now moving on. Knowing that, let's go ahead and work a little more with bases raised to a 0 power. So here I would read this as negative 4 to the 0 power. Again, anything to the 0 power is 1. So I'm going to write 1. Number 7, 10 to the 0 power is just 1. Here, notice I'm not going to read this as negative 8 to the 0 power because here there is no parenthesis surrounding the 8. Therefore, I would read this as the opposite of 8 to the 0 power. Okay, so I'm going to say that word opposite for a second because it's the opposite of 8 to the 0 power. Let's just do 8 to the 0 power is 1. But then I have to take the opposite of it, so it's negative 1. Here, 3 times 4 minus 1, all raised to the 0 power. Okay, here if you want to, you can totally simplify it and say, okay, 3 times 4 is 12. 12 minus 1 is 11. 11 to the 0 power is 1. Or you can just remember that any number raised to the 0 power is just simply 1. Okay, number 10. Again, I would read this as the opposite of 6 to the 0 power because there's no parentheses indicating that this base is negative. So the opposite of 6 to the 0 power. First, what is 6 to the 0 power? It is 1. And then you have to take the opposite of it, so it would be negative 1. So now what I would like you to do is go ahead and pause this video and try numbers 11 through 15. Okay, so let's quickly go over the answers. Number 11, negative 5 to the 0 power is 1, because again, anything raised to the 0 power is 1. Here, the opposite of 1 to the 0 power would be a negative 1, because 1 to the 0 power is 1, but then you have to take the opposite of it, which would give you negative 1. Number 13, 4 to the 0 power is 1. Number 14, again, you can totally simplify what's in the parentheses, or just remember anything raised to the 0 power is just simply 1. And for number 15, the opposite of 5 to the 0 power, well, what's 5 to the 0 power? 1. Then you have to take the opposite of that, so that would give you negative 1. Okay, so it says here, rewrite the expression with positive exponents and then evaluate. Okay, so first, what we're going to do is whenever we have a negative exponent, we want to start at a baseline. And this baseline is going to be the base raised to the 0 power. Why is that the baseline? Because 0 is when a number is not negative, nor is it positive. So here, we're going to start with 4 to the 0 power, which is 1. So here, instead of multiplying 4 2 times, I'm going to actually divide by 4 2 times. So I'm going to have to divide by 4 2 times. So I'm going to write 4 squared. So this is going to leave me with 1 over 16, and that is my answer. Okay, what about number 17? Again, since this is a negative exponent, we're going to first start with 2 to the 0 power, which is 1. And since it's negative exponent, instead of multiplying by 2 cubed, I'm going to divide by 2 cubed. This is going to leave me with 1 over, let's go off to the side, 2 times 2 is 4 times another 2 would give me 8. Again, the most common mistake is some students are going to say this is 6, and that is wrong. So be very careful that you don't make that mistake. Multiply it out. 2 times 2 is 4. 4 times 2 is 8. So again, if you're ever in doubt, just totally multiply the numbers out, and that should clarify things for you. Number 18. Here, since my exponent is negative, I'm going to go ahead and start with 5 to the 0, which is 1. And because it's a negative exponent, I'm going to divide by 5 3 times. So that's going to be 5 cubed. So as I simplify it out, I'm going to have 1 over. Here, 5 times 5 is 25, times another 5 is 125. So I'm going to say 1 over 25. Okay, so moving on. Number 19. Ooh, now we have negative bases instead of positive bases. Is anything going to change much? Not at all. So here, what you're going to do first, because you have a negative exponent, you're going to start with negative 4 to the 0 power, which is 1. And then here, instead of multiplying, I'm going to divide by a -4. Do I need parentheses? Absolutely. We know that we need parentheses whenever our base is a negative or whenever it's a fraction. So here I'm going to divide by -4 two times, which is going to look like that. And then this is going to leave me to 1 over, let's write it out real quick, -4 times -4. That's going to be a positive 16. Okay, number 20. Now, real quick, let me just show you an alternative way of writing it so that you can see. It's going to take a little bit more time, but it's a good way to see why. So again, since we have a negative exponent, I'm going to start with -2 to the 0 power, which is 1. Because it's a negative exponent, I'm going to be repeatedly dividing. So I'm going to do 1 divided by -2 3 times, which looks like this. Okay, but as a simplified exponent, we would write it as 1 over -2 cubed. And again, I really need those parentheses to indicate that base is negative. Now, why is writing it out like this helpful? Because when you're asked to evaluate, it makes it a little bit easier. Now we have 1 over. Well, negative times a negative is a positive. Positive times a negative is a negative. So I know my answer is negative. 2 times 2 is 4. 4 times 2 is 8. So there is an advantage of having it extended out like this so that you can see. Okay, number 21. So I'm going to go ahead and practice it like that. Since it's a negative exponent, I'm going to first start with my baseline of -8 to the 0 power is 1. Since it's a negative exponent, I'm going to do repeated division. So I'm going to divide by -8 a total of 2 times. So I would rewrite this as 1 over -8 squared. So I'm going to go ahead and evaluate that. A negative times a negative is a positive. 8 times 8 is 64. Okay, so I'm just going to do 3 more with you, and then I'm just going to leave it up to you to try it on your own. So number 22, here, this is not a -9 raised to the negative second. This is the opposite of 9 raised to the negative second. So what is being raised to the negative second power? Just the 9, not the negative. So what am I going to do? Again, I'm going to raise 9 to the 0 power, which is 1. And I'm going to repeatedly divide by 9 2 times. But guess what? There's still an opposite, or you can say negative, but you're going to still keep that on the outside. So this would be rewritten as the opposite of 1 over 9 squared. That would be my simplified exponent, and this will be evaluated to -1 over 81. Okay, how about number 23? Same idea. What is being raised to the -4th power? It's just the 5. It can't be a -5 because then there was parentheses. And again, you would read this as the opposite of 5 to the -4th power. So because it's a negative exponent, I'm going to start with 5 to the 0 power, which is 1. Because it's negative, I'm going to do repeated division. I'm going to divide by 5 4 times. Okay. And then here, we can't forget about taking the opposite, so we want to leave it on the outside. And so I'm going to simplify this to the opposite of 1 over 5 to the 4th power. So now this is going to lead to a -1 over, I'm going to do some side work, 25 times 25. That's going to be 625. So my answer is -625. Okay, last but not least, here we would read this as the opposite of 3 to the -3rd power. So here, just the 3 is being raised to the -3rd power. So again, I start with the baseline of 3 to the 0, which is 1. I'm going to repeatedly divide by 3, a total of 3 times. But of course, we can't forget our negative or saying the opposite on the outside. So this is going to simplify to the opposite of 1 over 3 cubed. But then to evaluate, this would give me -1 over 27. Okay, so now at this point, go ahead and pause the video and go ahead and finish the rest of the examples on your own. Okay, so now I'm just going to go ahead and reveal the answers to you. That way you can kind of check. Number 25, the answer is going to be negative 1 over 27. Number 26, the answer would be negative 32. Number 27, the answer is negative 1 over 32. And again, if you would want to see how I got these answers, please check out the work. Okay, moving on. Number 28, the answer would be 1 over 3 to the fourth. Number 29 would be negative 8. Number 30 would be negative 1 over 216. Last page, number 31 would be negative 1 over 256. Number 32 is going to be 1 over 49. And then number 33 will be negative 64. So feel free to pause the video, check out the work, and see what you did wrong or if you got the answers right. Okay, so that's actually going to conclude the lesson for today. Thank you so much for tuning in, and as always, until next time, bye.